Can Codex GPT 5.6 Sol build a TICRA GRASP-like tool in MATLAB and Octave without me writing a line of code? In this short video, I will show you the final result. You'll find the link for the GitHub project in the description below. After startup, you can create your dual reflector design with a Gaussian beam source and several polarizations like in the TICRA GRASP wizard. You can choose between a Cassegrain, a Gregorian, or a ring focus design and have a closer look at the conics and their construction parameters. In the Power and Ray Tracing tab, you can do a quick ray tracing of the system and have a look at the power in the ray tubes. Let's go on with the default Cassegrain design and set exactly the same system up in the TICRA GRASP 24 Student Edition. We will simulate at 2 GHz with 6000 far-field points per cut using physical optics and physical theory of diffraction, fully implemented by Codex. Let's have a look at the simulation in real time. The simulation time in TICRA GRASP was 7.5 seconds. In the Dual Reflector Designer, 3.6 seconds. If we now import the TICRA data into the Dual Reflector Designer and compare both results of the total copolarization, we don't see any differences. From my point of view, a pretty nice result. Let's go on with the same system at 30 GHz and with 90,000 far-field points. For better comparison, I imported the discretization points from TICRA GRASP. As you can see in the TICRA results, the simulation time was 2 hours, while the simulation in the tool took only 53 seconds. Once again, the TICRA simulation results were imported, and as you can see, there are no differences in the final pattern, not even when we zoom in on lower regions. Finally, I want to present you the results of the implemented experimental convergence test. Experimental because it's actually not as fast as the TICRA convergence test. Sometimes it might not converge or use more points than necessary. As you can see in the pattern comparison, the pattern from the convergence test with higher PTD settings shows less variation over all phi cuts. In a full symmetric setup with circular polarization, there should be no variations between phi cuts, so that's a pretty nice result. Let's have a look at all the benchmark results. I also did a 100 GHz test with the same setup as you can see in the table. The whole program, including physical optics and physical theory of diffraction formulas, was written by Codex. I literally did not write one line of code. If you are interested in installing the Dual Reflector Designer, I recommend to install it using Codex GPT 5.6 Sol. Run the agents.md and let Codex adapt the source code to your hardware. There's also a Windows installer available, but I can't guarantee that it is running as expected on your particular hardware. If you found this helpful, leave a like, subscribe, and let me know what you think in the comments. Thanks for watching, and I'll see you in the next video.